Today we're going to talk about multiple representations of linear relationships. And so basically we're looking at a situation and we're going to use the data from the situation to create a table, and we'll look for the rule and we'll write an equation from it, and then we'll plot it on a graph. So let's begin. Our first problem is the students at Grove Middle School are selling popcorn as a fundraiser. The school receives money for every box of popcorn sold. So we can see that there's an independent and there's a dependent quantity here. Which one depends on the other? What can we change that affects something else? So it looks like the popcorn sold is going to affect how much money is made. So the popcorn sold is the independent quantity, and depending on how much we sell will be the money earned. That is a dependent variable. That's our money earned. Okay? So now that we know that, we can take our data and we can put it on a table. So again, let's start off with what is our independent variable? That's our x variable. And which is a dependent? It's the y. Okay? And then the labels are, like we said, the popcorn sold is independent and the money earned is the dependent. Okay? And the relationship between the two is what's called the expression or the rule. So let's think about it. When we put in 5, when we sell 5 boxes, we make $12.50. If we sell 10 boxes, then we make $25. So what's the relationship? Can we add something to 10 to make 25? Or can we multiply something to get to 25? Well, since I know that something times 10 gives me 25, I can also think about it as 25 divided by 10 should give me what the other factor is. So let's take a look. We can take 25 divided by 10, and as it turns out, 25 divided by 10 equals 2.5. So let's see if this rule works. So we're saying that 2.5 times 5, if that's the rule, should give us 1250. And it does. What about 2.5 times 10? Yes, because if we move this decimal point to the right once, we will get $25. Okay, and what if we multiply 2.5 times 20? Yes, well, if we double 25, it's 50. So that rule holds. So we can say that is our expression. So now that's all that's left for us to do is to write an equation. Well, an equation is just simply using the expression and setting that equal to y. So it becomes y equals 2.5, which is our process, times whatever x is. And that's our equation. Now let's see if you can try it with this second situation B, with Maria bakes and sells cakes of different heights. Each cake she bakes is served on a standard cake board. The total height of the delivered product includes the height of the cake and the height of the cake board. Pause this video and see if you can solve this problem on page 1 of your packet, and then start the video again to see the solution. Okay, let's see what you decided is the independent quantity. What is the factor that we can change that affects something else? Well, it looks like the height of the cake is the one that changes. So we have the height of the cake, or the cake height, and then we add that to the standard cake board height, and we come up with a total height. So the total height depends on the cake height, because the cake board is the same for every cake. So now we have to say, so now that we know that the cake height is an independent quantity, let's make sure that we remind ourselves that x is the independent variable and the y is a dependent variable. We have then the process, and think about what is the expression, what is the rule. So let's think about that. The expression. How do we go from x to y? So if I put in 5, I get 5.5. If I put in 10, I get 10.5. Well, is it an additive relationship or is it a multiplicative relationship? So let's think about that. 5 plus something gives me 5.5. So could it be 5 plus 0.5 or 5 tenths gives me 5.5? Okay, so 5 plus 0.5 gives me 5.5. And so 10 plus the same 0.5 is 10.5. Well, if 5 represents the height of the cake, what is this 0.5? Well, this 0.5 represents the height of the cake board because it's supposed to be the same for every cake. So that means that the next cake, if the cake is 15, I guess, inches tall, then it would be 15 inches plus 0.5, the height of the cake board. And the same thing for this. It would be, if the cake was 20, then this would be 0.5. And then finally, then we would have, if the cake was 25, then we'd add 25 to the height of the cake. And you should end up with a 25.5. So now what would the equation be? Well, the equation again is just our expression set to y. So that would be y equals x, whatever the height of the cake is, plus the height of the cake board. Now let's look at another problem.